Namaskar. So today we are going to solve one more question from differential calculus and the Leibniz theorem. So let's start. So it says that if y is e power a sine inverse x, then we have to prove this equation. Hence find the value of yn when x equals to 0. Fine. So let's jump into the question. So we have y equals to e power a sine inverse x. Fine. Now what can we do with this? Let's differentiate with respect to x both sides. So derivative of y is y dy by dx or y1, whatever you write. So I am writing y1 is derivative of e power something is e power something. Then you go inside and by chain rule you say that derivative of sine inverse x is 1 upon under root 1 minus x square. But this thing is again y only. So y1 is ay divided by under root 1 minus x square. If you square both sides, you get y1 square is a square y square divided by 1 minus x square. Send this term to the other side. So 1 minus x square y1 square, okay, and minus a square y square equals to 0. Now again differentiate. So 1 minus, let's write differentiate with respect to x. So 1 minus x square as it is, derivative of y1 square. So first of power, so power comes at front, power is decreased by 1. Now derivative of y1 is y2 plus y1 square as it is, derivative of 1 minus x square is minus 2x. Here you come, so derivative of y square is 2y, so 2a square y, and further derivative of y will be y1 equals to 0. Now as you can see, 2y1 can be thrown outside, that means to the arches from each of the terms. So you get 1 minus x square y2 minus x y1 minus a square y, because 2y1 is thrown. This equals to 0. Now we will differentiate this equation any times with the help of Leibniz theorem. So let's write this once again. So 1 minus x square y2 minus x y1 minus a square y is equals to 0. Fine. Now differentiate this above equation any times using Leibniz theorem. Fine. So how to do that? चूज पहले कर लेते हैं कि किसको हमें n टाइम्स डिफरेंशिएट करना है. तो y वाले टर्म को n टाइम्स डिफरेंशिएट कर लेते हैं, क्योंकि ये जो x वाला टर्म है वो तो anyway it is going to be finished in 1 or 2 steps. So that term remains as it is in Leibniz theorem. First of all, you have nc0. The term which will be finished after 2 or 3 steps remains as it is in the first term. differentiate y to n more times. It is already differentiated 2 times, differentiate it n more times. So you get yn+2, then you get nc1, then derivative of this will be -2x, then decrease derivative by 1, so yn+1, then again nc2, again differentiate this -2x, so you get -2, decrease this derivative again by 1, so you get yn. Do the same with the second term, so nc0, differentiate y1 n more times, so yn+1, and this -x as it is, plus nc1, derivative of -x is -1, differentiate, make derivative 1 less, so this becomes yn. Now if you differentiate it once more, it will become 0. Same was true for the last one also. So now this a²y, so derivative of y n times will simply give you yn, so a²yn equals to 0. Now collect the like terms. One thing you will have to notice that nc0 is 1, nc1 is n, and nc2 is n-1 divided by 2. So nc0 is 1, so you get 1 minus x squared yn+2. Okay, and with yn+1 you have this nc1 which is n, multiply with this 2, -2, so -2n. Okay, x also if I write outside only, so -2n. Any more terms containing n-1? This term nc0 is 1, so you are getting this -x also from here, so -1. Okay, now terms with yn, so this is n-1/2, this will get cancelled, so you are left with n-1, that is n² minus n with a negative sign. Any other terms of yn, this is yn term, and it is nc1 which is n with a negative sign. So and also for yn you are having -a² also. So 1 minus x² yn+2, and minus if I take common, so 2n+1 yn+1x plus this will be plus n minus n will get cancelled. You are left with -n² minus a². So again I can take minus sign common. N was already cancelled, so minus sign common between -a and -a² minus n². So a² plus n² yn equals to 0. Let's check whether we are on track or not. 1 minus x² yn+2 minus 2n+1 x yn+1, fine. a² plus n² with a minus sign and yn, correct. So we have proved this, but they are asking one thing more, which is the lengthier part of this question, and that is hence we have to find the value of yn when x equals to 0. Okay, so that will need some research, research in the sense you have to write certain values. So yn when x equals to 0. Okay, let's write this as equation number, this as equation number 1, then this as equation number 2, this as equation number 3, and this as equation number 4. All these will be helpful ahead. Now I'm saying that when x equals to 0, they are finding the value, asking the value of yn. So when x equals to 0, let's put x equals to 0 in equation number 4. So this middle term will vanish because at x equals to 0, this will be 0. And here, from here, you will get yn+2 only. Okay, yn+2 from here. Okay, and let's see. So you are getting, put x equals to 0 in equation number 4. So we are getting, take this negative term to the right, so we are getting yn+2 and this we are calculating at 0. I am writing 0, that means x equals to 0, equals to, this goes to the right, becomes positive a² plus n² yn. No terms of x was there. A² plus n² yn, and this also yn we are calculating at x equals to 0. Okay, so this is what we are getting. Fine. Let's name this equation number 5. Okay. So if you put n as 0, you get y2 at 0. At 0 means at x equals to 0, equals to n as 0, that means you are getting a² and yn at x equals to 0. So y2 at x equals to 0 I can get from this equation, this third equation. So y2 at x equals to 0 will be y2 equals to a² and y at x equals to 0, because everywhere you are putting x equals to 0. So this is written as y, but this was also, you know that this y was a function of x only. Okay, so for this again we'll need y at x equals to 0. So for that, refer to equation number 1. So y at x equals to 0 is, sin inverse 0 is 0, so e power 0 is 1. So you are getting y2 as a², because value of y at x equals to 0 is 1. So y2 is a² equals to a². Wait a minute. So I put n equals to 0 here. So here again it will be n y0, and y0 is nothing but y only, because y0 is when you haven't differentiated a single time. So y0 is same as y. So you would have calculated this from individual equations also. So y2 as at x equals to 0 you are getting as a square y at y0 at x equals to 0 you are getting as 1. And what about y1? Y1 you can calculate from this equation, put x equals to 0, so you get as y1 is a times y, and y at x equals to 0 is 1, so y1 is a. Y1 at x equals to 0 is a. So these three things we calculated. Okay, let's use them. So if in equation for equation number 5, put n as, start putting the value of n as 1, 2, 3, 4 and so on. So if you put the value of n as 1, you get y3 at x equals to 0, and that is a square plus 1 square, and here again y n means n you are putting as 0, so y0 that is same as y at x equals to 0. So y at x equals to 0 is 1, so you are getting y3 at x equals to 0. Simply in that step only, if I write y at x equals to 0 is 1, so y3 at x equals to 0 you are getting as a square plus 1 square. Now again put n as 2, so you will get n plus 2, that means n plus 2, 2 plus 2 4, so y4 at x equals to 0 is a square plus 2 square, and y2 at x equals to 0, y2 at x equals to 0 is a square, then put the value of n as 3, so you get y5 at x equals to 0, so that is a square plus n square, and you have put as 3, so 3 square, and then you will get here y3 at x equals to 0. So y3 at x equals to 0 you can get from here only, so that is a square plus 1 square, okay. Fine. Wait a minute. In while calculating y3, let's calculate y3 once again. So y3 at x equals to 0 is a square plus, and we put as 1. Let's write in order to invite confusion. N equals to 1, n equals to 2 and n equals to 3. So you put n equals to 1 here, so a square plus 1 square, and it will be y1 at x equals to 0, and y1 at x equals to 0 is a. So in expression of y3 1a will come, so here also a will come. Now calculate for n equals to 4, so when n equals to 4 we will get y6 at x equals to 0, so that will be a square plus 4 square, and then you will get y4 at x equals to 0, and y4 not y4, yes, y4 at x equals to 0 you have already obtained. Paste that here, so that is a square plus 2 square. Calculate for n equals to 5 for the last time, so this will give you y7 is equals to 0. So this will be equal to a square plus 5 square, and with that you will get n equals to 5, so y5 at x equals to 0. So that is a square plus 3 square, a square plus 1 square times a. So are you able to find any pattern? So if n is odd, so when n is odd, you are getting this, this, and this. And for n equals to even, you are getting this and this. Obviously, we can find for 6 also, but this is enough. So what pattern I am asking you to check? That you are getting a square in even, n equals to even terms, and a in odd terms. Okay, that is the first observation. Second observation is, when it is odd, you are getting a square plus 1 square, a square plus 3 square, then it will be a square plus 5 square. So a square plus 1 square, a square plus 3 square plus a square, whatever you are finding, that minus 2 wholes, now that minus 2 square. Okay, so that is one more thing. So based on that, we can finally write the expression for yn. I think that's what they asked for, yn. So while writing for yn, it will be of two types. When n is odd, then the expression of yn equals to a square, first of all a, then a square plus 1 square, a square plus 3 square, this will go a square plus n so when n equals to 3, let's say, was there, so this subscript I am talking what, if this is 5, so that will come as n minus 2 square, and when n is even, it will come like a square plus 2 square, a square plus 4 square, and then finally what you will get, a square plus 2 square, a square plus 4 square. So you get, again there also you are getting a square plus n minus 2 square. Fine. So this is the case.